Hello friends, welcome back to your UPSC. Today in oceanography we will be completing temperature and salinity distribution of ocean surface along with its heat budget and salt budget. So let's get started. We all know that 3/4 of our earth is covered with water, which is majorly in ocean surfaces and sea. Okay, so the temperature distribution of sea and ocean surface has a great significance from the geographical point of view. How? That we'll see. First of all the physical and chemical properties of the seawater are determined by it. Now, how the physical and chemical properties, along with the biological properties of the seawater, are determined by the temperature? See, if we have higher temperature, then the rate of evaporation will be more. Okay? And if the rate of evaporation is more, then the salinity will be more. And if the salinity is more, then density of the water will automatically increase. Okay, so this is how in various ways temperature it influences physical and chemical properties along with the biological properties of the seawater. Next we have causes oceanic current and other water movement. See, we all know that oceanic currents are formed due to temperature gradient that is formed between the surfaces. Okay, so the oceanic currents and other water movements like waves, drifts, all these are formed due to one of the factor for their formation is temperature. Next, it maintains the heat budget of the earth. Now, because 3/4 of our earth is covered with water and the solar radiation, maximum solar radiation falls on the water, so because the water have specific heat capacity more than land, so it cools down also very late and it heats up also very late, so it takes time to cool down and heat up. So this is how it maintains temperature of earth. Okay, next we have accounts for distinct type of marine and continental type of climate. So continental type of climate and marine type of climate are accounted because of temperature of ocean water. And the coast along the coastal region, the temperature is moderated by ocean water. How? By land and sea breeze that we have already done. So these are the significant role that temperature plays. Now we will look into heat budget. First we will look into sources of heat. The main source of heat is absorption of solar radiation. So the solar radiations which come on the earth, they are directly absorbed by the ocean, and this leads to increase in temperature of the ocean water. Next is convectional current. The convectional current that are originated in ocean along with the atmospheric convection is the source of heating of ocean. Next we have conductional heating. See, we have bottom surface of the earth and this bottom surface of ocean, sorry. So this bottom surface, due to various region, the geothermal heat is evolved and this geothermal heat is transferred, and via conduction the water is heated up. Okay, next we have conversion of kinetic energy into heat energy. We all know that by the law of conservation of energy, heat is neither destroyed nor created. Okay, it just changes from one form to another. So when kinetic energy it changes to heat energy, This heat energy, it increases the temperature of ocean, thus leading to source of heat, okay, as the factor of source of heat. Next, we have chemical and biological processes. Various chemical and biological processes like uh, we have various exothermic processes that releases heat, and this release in heat causes increase in temperature. Likewise, we have various biological processes that also act as a source of heat. Then we have various radioactive disintegration in the seawater. They can be both anthropogenic factor and natural factor, and this disintegration, it leads to increase in temperature of the ocean water. Now the last factor, it is not as significant as the others, but the condensation of water vapor on the sea surface, and because the water vapor, when they condense, they have quite high temperature at that time too. So as soon as they come on water surface or sea surface, they increases the temperature of sea surface. Now how this incoming heat is expended, okay, so the expenditure, this was income, now we will look into expenditure. Now heat received from radiation is radiated back. The heat that is received from solar radiation is radiated back to the atmosphere in the form of long waves, that we all know that solar radiation, they are always in the form of short waves, while the terrestrial radiation, they are in the form of long waves. And this heat is radiated back in the form of convection and evaporation. So these are the two processes that are involved to expand or to radiate back the heat energy that was received. Now we will look into surface temperature of ocean water. Surface temperature of ocean water, its distribution is very complex. Okay, so the surface temperature of ocean water, when we look into its distribution, it's very complex. But if we talk about annual average temperature of open ocean water, on an average, the temperature, it decreases from equatorial region towards the pole gradually. Okay, so at 0 degree to 10 degree latitude, it will be 27 degrees Celsius. Then at 20 degree latitude, it will be 23 degrees Celsius. Then when we go further up, it will be 40 degree latitude, and here the temperature will be 14 degrees Celsius. Then we will have 60 degree latitude where the temperature will be 1 degree Celsius, and at the poles we can see that the temperature is minus 8 degrees Celsius, and this temperature is the freezing point of saline water. Okay, now what are the factors that affect the distribution of surface water? First is latitudinal extent. So latitudinal extent of water are the major factor that affect the distribution of surface temperature. Next is our ocean currents. Ocean currents, actually what happens, the ocean current, when the cold current, they reaches to the areas having higher temperature, they decreases the temperature of the surface water present there. Okay, so this is how, and vice versa will happen when the warm current will move towards the colder places. Okay, this is how ocean current will affect. Next we will have prevailing winds. So the prevailing winds, like if we have warm winds that are moving over ocean, so these warm winds, by the process of convection, they will heat up the surface of ocean. Okay, then local weather condition also in the similar way affects the temperature of surface water. Then we have another point, the winds, like we have trade winds and other winds, they actually take the surface water from one area to another. Like if they take water from warm area towards the colder region, then what will happen? The warm water from here will get piled up in the cold region and thus increasing the temperature of the colder places. So this is also one of the way that the prevailing winds are affecting the surface temperature of ocean water. Now we will look into the range of sea surface temperature. The range of sea surface temperature, whether it be diurnal or annual range, it is much less than the land due to specific heat of water. Okay, so because of specific heat of water, water gets takes time to heat up and it takes time to cool down. So if we talk about the diurnal change in diurnal range of ocean water, then it tends to decrease towards the higher latitude. So as we go towards the higher latitude from the equator, whether in north or south, it tends to decrease. Okay, so like for example, if the diurnal range of the temperature at equator is, just consider it to be 1 degree Celsius. Okay, then the diurnal range of temperature at the poleward side will be just about 0.4 degrees Celsius. Okay, so this is an example. The diurnal range of temperature is also affected by cloudiness and breeze. Now, how it is affected by cloudiness and breeze? See, if we have clear sky, then diurnal range of temperature will be more as compared to cloudy when we have clouded sky. And the breeze also affect, like if we have cold breeze, then the range of temperature will not be that high, and if we have calm atmospheric condition, then the range of temperature will be more. Another thing about diurnal range of temperature, the maximum variation in temperature will be noticed at the time of 2 p.m. Okay, and minimum variation will be noticed during 4 to 5 a.m. So it can also be written as, okay. Now talking about annual range of temperature, annual range of temperature is also much less than the that of the land. Why? Because of specific heat of water. And this annual range of temperature, it depends on radiation income, then nature of ocean current, and lastly prevailing winds. So the amount of radiation that are coming, they affect the annual range of temperature, and the nature of ocean water current, that whether the see firstly the amount of insolation or the radiation that this ocean, the part of ocean water will get, it will affect the annual range of temperature. Next, the nature of ocean current, like if this area is affected by warm ocean current or cold ocean current, this will also affect the annual range of temperature. Lastly, we will have prevailing winds. Prevailing winds will also affect the annual range of temperature. If the prevailing winds are bringing cold water with them, or they are being cold, or they are cold, then the range of temperature will be less as compared to when they are warm. Okay, now the annual range of temperature, if we see at 0 degree latitude or at the equator, it will be 2.3 degrees Celsius. At 10 degree latitude, it will be 2.4 degrees Celsius. This is range of temperature. Okay, so the range of temperature is maximum along, sorry, it is maximum along 40 degree latitude. Okay, now we will see at 10 degree latitude it will be 2.4 degrees Celsius. Then at 20 degree it will be 3.6 degrees Celsius. Then 30 degree it will be 5.9 degrees Celsius. Then 40 degree it will be 7.5 degrees Celsius. It will be maximum at 40 degrees Celsius degree latitude. Why it will be maximum? Because this area will receive quite a ample amount of sunlight during summer, and during winter it will be very cold region. So the range of temperature will be highest, and as we go further upward towards the pole, then the range of temperature will again decrease to, at like we have at 50-degree latitude we will have 5.6 degrees Celsius as the range of temperature. Okay, because here the summer will not be that warm as compared to 40-degree latitude. Okay, and here the summer are warm, but the winter are not as cold as in polar region. So here we can experience both quite warm summer and quite cold winters. Okay, that's why the range of temperature is highest at the 40-degree latitude. Now, at the subsurface layer, we also have annual range of temperature, and this layer is, there are various factors that are affecting the temperature, distribution of temperature here. First is difference in amount of heat. Okay, next is effect of heat conduction, the conductive heat that is coming. Next we have horizontal displacement of water masses and consequent change in ocean current. So the ocean current also affects the surface layer and subsurface layer. Then we have excuse me, we have vertical motion. This vertical motion of water also affects the subsurface layer or the temperature at subsurface layer. Now we will look into the vertical distribution of temperature of ocean water. Okay, so we have this chart which will depict the vertical distribution of temperature of ocean water. So this represents higher latitude, these are of mid latitudes, and these are of low latitude region. Okay, first we will start with lower latitude region, that is from 0 to 30-degree north and south. Here we will see that till 1000 meters of depth there is a steep change or steep decrease in temperature of the water. So from the surface, that is we are having the temperature of 25 degrees Celsius, and when it reaches towards the till the depth of about 1000 meters, its temperature will decrease up to 4 degree or 3 degrees Celsius. Okay, now we have mid latitudinal region. Here also we will notice a decrease in temperature, but this decrease in temperature is not as steep as the decrease in temperature of lower latitudinal region. So it will be like 16 degrees Celsius on the surface, and it will decrease up till 1200 meters. This is approximate depth, it may increase or decrease. Okay, so here it will also come in or will be parallel, or the temperature will be same as the one of lower latitudinal region. Okay, so it will also decrease its temperature till 3 degrees Celsius or 4 degrees Celsius. Now we will look into polar region having on higher latitudes. So this was till 30 to 60 degree, and this will be from 60 to 90 degree. So here the temperature will be like 5 degrees Celsius on the surface, and as we go down, the temperature will, the decrease of temperature or the steepness slope will be very gentle, and the temperature will decrease very smoothly. Okay, now we will see that the layer which is from 600 meters till 2000 meter, here we can see maximum variation in vertical temperature of ocean water. Okay, so this I have drawn a little less or wrong, so consider like this area to be about 600 meters. This I have wrongly pointed. So this area where we can find maximum variation in temperature, this area, it ranges from 600 meters to 2000 meters, and here this area is known as the zone of permanent thermocline. Okay, and after that, after 2000 meter, we can see that there is no change in temperature. Okay, the temperature is almost constant, and the temperature of the water beneath the surface, or beneath this layer, this permanent thermocline layer, the temperature of the water of every ocean will be same. Okay, so this was vertical distribution of temperature of open ocean. Now we will look into vertical distribution of temperature of the adjacent seas. Now there are two type of adjacent seas in respect to temperature stratification. First, we will have adjacent seas in which the deep layer of water shows the lowest surface temperature recorded during the cold month. And these are like Mediterranean Sea, then we will have Red Sea. They fall in this category. Others, we have the surface temperature throughout the year is very high. The thermal surface of the sea is below the sill depth, okay, determined by the temperature. So the sill depth is also known as threshold depth, and the temperature will start decreasing after this threshold depth. Okay, and the sill depth or threshold depth is defined as the maximum depth of entrance for from the open ocean to the basin, to a basin. Okay, so here in this type of adjacent sea, the temperature will be determined by the sill depth. Okay, so the depth of the sill or the threshold depth will only determine the temperature after the sill depth. Okay, so that was all about temperature, vertical distribution of temperature, or and horizontal distribution of temperature. So we have done distribution of oceanic water's temperature, both horizontal and vertical, and we have also done the heat budget. Now we will look into salinity of ocean water. As we all know that one of the most important property of the water is its ability to dissolve a, a very large number of solid and gases without chemically reacting with them. Okay, so the water actually dissolves various or many solid gases and liquids also, and they dissolve in water without changing their chemical properties. Okay, now because of such property, we have salinity in ocean water, and salinity in ocean water or salinity can be simply defined or referred to as the concentration of dissolved salt in water, and we can also say that the amount of salt dissolved in 1 liter of sample seawater. Okay, so this was about this is the salinity, that is the amount of salt that is present in 1 liter of sample seawater. It determines its salinity, and the salinity is measured in part per thousand. Okay, the ratio of amount of different salt that are dissolved in water, or ocean water, they are always constant. See, now we can say that some may confuse that, then how this ratio can be constant when we have different salinity in different areas or different latitude. But here we are talking about the proportion of salt, various type of salt that is present. So consider this as amount of NaCl, this is amount of MgCl, this is MgSO4 and CaSO4. So they are salt. Okay, so consider it to be 1/4, this to be 1/4, this and this to be 1/4. Okay, so this is just an example. Okay, so the packets may differ, or the number of packets may differ, but the proportion of salt present in each packet is same. Okay, so the ratio of the salt that will be, of the different type of salt that will be present will always be same. Like NaCl will always be 78% in total amount of water that is present, total amount of salt that is present in the water. Then MgCl will be 10.7%, MgSO4 will be 4.5%, CaSO4 will be 3.5%. These are major or the main salt components that are present in ocean water. And the average salinity, if we see, is 35 part per thousand. Okay, now salinity of ocean water, it influences in various ways. So the basic influences of salinity, first is distribution of marine organisms. So the marine organisms, their distribution depends on salinity. How it depends on salinity? See, the more the salinity, the less the marine organisms will be present. So the more the salinity in the area, the less the microorganisms, whether it be plants or animals. So both will be present in less amount. Okay, then the density, the more the salinity, the more the density of the seawater will be. Next we have refractive index. As the density of the seawater or the water will increase, ocean water will increase, the reflective index of the water will also increase along with it. Okay, now along with these, the salinity also influences osmotic pressure, viscosity, diffusion, conductivity, compressibility, scattering and surface tension of the water, seawater. Now what are the sources of salinity in seawater? First is rivers. So the rivers, they cut the rocks and they bring the salt with them, and this river, they at last they drown in seas, and this increases the salinity of sea. Okay, then we have marine organisms. The marine organisms also, they also extract, sorry, they also releases some salt, like we have coral polyp, mollusk, oyster. So these type of organisms, they have carbonate of lime. So this carbonate extract, it when mixes with seawater, it increases the salinity of seawater. Next we have seaweeds, glaciers, wind, waves, submarine volcanoes. These are also important factors which increases the salinity of seawater. Now what are the factors that causes variation in sea salinity? So the salinity variation in salinity can be caused due to, first is rate of evaporation. See, rate of evaporation is directly related to temperature, and when there is more rate of evaporation, that means the temperature is high, and because there is more rate of evaporation, the salinity of the area will be more. And the rivers, they actually bring with them fresh water, and the area near the river will have comparatively less salinity as compared to other areas. But if the river are bringing, sorry, this is how the river brings fresh water with them, and this decreases the salinity of the area. Now mixing and movement of oceanic water. So the oceanic water, it moves from one place to another, and because of mixing of oceanic water, due to currents and various other oceanic movements. This water mixes, and this, when the area of high salinity, it mixes the water from the area of high salinity, it mixes with the water of area of low salinity. Its salinity will increase. The area, the low saline area, here the salinity will increase, and if the vice versa will happen, the salinity will decrease. Next we have supply of fresh water through precipitation. Lastly we have winds. So these are the causes of variation in salinity. Now we will look into horizontal distribution of salinity. So the horizontal distribution of salinity, we can see that in an open ocean of the world, the average salinity range is about 33 to 37 ppm, and in subtropical region we can see highest salinity, and subtropical region ranges from 20 to 25 degree north and south, and this high salinity is due to low precipitation, negligible river discharge, and high rate of evaporation in this area. So this area is having highest salinity. And as we go towards equator side, so when we go towards the equator side, that is lower latitude, this is 20 degree to 25 degree latitude. Now when we go towards the equator, that is 0 degree latitude, the salinity will decrease. Okay, so the salinity will eventually decrease. And why we have low salinity in this area as compared to the subtropical region instead of having higher temperature? This is because heavy precipitation occurs in this area, and due to heavy precipitation, the salinity, because this area gets fresh water from the precipitation, so the salinity is less. Then we have retardation of evaporation. Now because we have the convectional rainfall that happens in the equatorial region, because of this convectional rainfall we have formation of cloud during afternoon time. Okay, so these clouds, they block the solar radiations to come and heat up the water surface so that the water can evaporate. So the rate of evaporation, it retards, and because of this, what will happen, the salinity of the area will be less than that of subtropical region. Lastly, we have many freshwater river that discharges into ocean, the equatorial area. Thus the freshwater, we have less salinity in this area as compared to subtropical region. And lastly, we have poleward side. As we go upward towards the pole or higher latitude, we can see that this salinity from subtropical region, the salinity gradually decreases. Now this decrease in salinity is due to low rate of evaporation, and secondly it is due to melting of ice in summer. So when the ice melts, the ice is said to have containing the fresh water of the earth. Now because the fresh water it melts, so the salinity of this polar region is less. Okay, so we have highest salinity in subtropical region. This was the horizontal distribution of open ocean. Now if we look into horizontal distribution of landlocked seas, then we can see that, or landlocked sea and adjacent seas, then we can see that in tropical and subtropical region, the salinity of landlocked sea will be more than the salinity in inland sea, while in temperate and polar region, the salinity in inland sea will be more than that of landlocked sea. Reason being, in tropical and subtropical region, the landlocked sea, it is having restricted exchange with open ocean and seas. So, and because it is situated in dry and hot region, we have rapid rate of evaporation, and beside that we have scanty rainfall and very little stream flow. And because of this, the salinity of landlocked seas will be very high in tropical and subtropical region as compared to the inland sea. because in inland sea we have connection of inland sea with various freshwater rivers, and this brings in fresh water in the inland sea while it has restricted connection with the open ocean. Thus the salinity of inland sea will be less in the tropical and subtropical region, while in temperate region it will be just opposite, because the inland sea, it will be having restricted connection with the open ocean, and here, because it has connection with land, the area will be having comparatively higher salinity in inland sea than the open ocean. And the landlocked sea, because here we will have low rate of evaporation, so the salinity, and plus during summer it will be supplied with fresh water of glaciers, so the salinity in this area will be comparatively less in landlocked sea as compared to inland sea in temperate and subpolar region. Okay, so we can take example of Red Sea. So the Red Sea has an average salinity exceeding 40 ppm, and the Mediterranean Sea has the average salinity ranging from 18 to 39 ppm, subjected to its proximity to discharge of fresh water. Okay, and then we can take the example of enclosed sea or inland sea. Inland sea. Here we have Lake Van in Turkey, which is the saltiest inland lake. Here the salinity touches the the salinity at the is highest, and it is about 330 ppm. Okay. Then we have Dead Sea, where the salinity is 237 ppm, 37.5 ppm. So here, due to restricted opening in tropical and subtropical region, due to restricted opening, the salinity reaches to very high value. Okay. Now we will look into vertical distribution of salinity. But before looking into vertical distribution of salinity, we will look into annual variation in temperature, annual variation in surface salinity. So the annual variation in surface is salinity is maximum in tropical region, and it decreases as it as we move towards the pole. Okay, so in tropical region we can see at here at so maximum variation is at subtropical region. Okay, now the maximum salinity, it occurs in March, and the minimum salinity, it occurs in November. So this is the annual variation of surface salinity. Now we will look into vertical distribution of salinity. At higher latitude, vertical distribution of salinity, we can see that in higher latitude, the salinity will first decrease, then it will increase constantly and steeply till the range of 250 meters, about 250 or 300 meters. So this is photic zone, and here the salinity will change, or the variation in distribution of vertical salinity at the higher latitude is little bit complex till this layer. This is known as surface layer. Now as we go down, the salinity will constantly decrease, but the rate of decrease will not be very high. Okay. Now in the area of mid latitude, during winter the salinity will increase, the salinity will decrease, but this decrease will be comparatively less, because here during winter the salinity will be comparatively less than the summer. Okay, so during summer the salinity will be very high because of rate of evaporation which will be high, and this region is known as the region of permanent thermocline. Here the salinity will decrease steeply, comparatively steep, then it will decrease smoothly. Okay. Lastly, we have the area of lower latitude. So in area of lower latitude, we can see a great range of variation in salinity. In At the surface, it was quite high, but as we go down, it steeply changes and the salinity steeply decreases until 1200 or 2000 meters. After here, the decrease in temperature will be smooth. Okay, and here the salinity of all the oceans will be same after the certain amount of depth. Okay, so this was vertical distribution of this we complete salinity of ocean water. So guys, that was all for today. I hope you enjoyed today's lecture. Let's meet in our next class. Till then, take care and have a nice day. Thank you.